Hi, welcome again. Today our question is find the shear force and bending moment of the simply supported beam. The beam at the right we have pin. At the right we have ruler. So here is ruler, one unknown, and here is pin. Here is two unknown x and y axis. This point let's have name is A, and this point is have name is B. Okay, so A and B. Just write the B for the B, this one is B. So here we have UDL. Okay, this UDL we will change it to point, so 3 kilonewton per meter, and the total distance is 2 to 5, so it's mean 3 to 3, 3 is 9, and 9 will be at the midpoint. Okay, 9 kilonewton will be at the midpoint, so its distance will be 3 divided by 2, so it's 1.5, and here is 2 meter. Okay, and the point load here is 20 kilonewton 3 meter from the ruler supported. Okay, this point is by, and this one is ay and ax. Okay, so there is no axis forces, so it means the axis will be equal to 0. So use f of y from equilibrium equation. The upward will be positive, and use f of y equal to 0. So it means the upward will be positive, the downward will be negative. So ay plus by, these two is going up, so that's why it's positive, and the 9 kilometers is going downward, so it means negative, and the 20 is also going downward, so it's also negative and equal to, there is no other process, so it's equal to 0. So ay plus by is positive, so leave it to the left, and these two go to both sides of the equal to, so it means positive, and this total will be 29. Okay, so just apply moment equation at any points p or a, doesn't make any difference. So let me apply it at a. So moment, this one is positive at a equal to 0. So the 9 kilonewton multiplied by 1 and 5, 1.5 plus 2, so it's mean 3.5. Okay, and the second one is also going positive because it's negative. This one is also this one, and this one is going different from these two, so it's negative. So just multiply 20 multiplied by to 0 to 7, so it's means 7, and also the other one is negative, so by multiplied by total distance is 10 equal to 0. By try to go to the right side, so it's 10, and the other is 20 multiplied by 7, so it's 140, and 9 multiplied by 5, 9 multiplied by 3.5, so it will be, let me calculate it, 3.5 multiplied by 9, 31.5. Okay, 31.5. These two will be plus and divided by 6, so by will be 28 point, no way. So here is, these two is positive, and this 10, so it's not by 6, it will be 10, so 31.5 plus 140 divided by 10. Okay, it's 17.5. I thought if one is 18, so how the second one will be 2 point something. So by here is 17.15, and the ay will be just 29 minus this answer, so we will get the ay. Okay, the answer is 11.85, it's 12 kilonewton. So we find the supports. Now cut the beam from the left side, so we will get the shear force and bending moment. So let me cut here. Just cut me here and cut here and here and here. Just 4 times, so you will get the answer. Okay. So uh, there is I get here. Okay. So this one is AY. So it's mean 11.85. Okay. Here is the normal force. Here is shear and moment. Okay. So there is no other force. So it's mean if you use the F of Y. Okay. F of Y here is minus V positive 11.85 equal to 0, so V will be 11.8. Okay, so use the moment equation. So it's positive, so M positive and negative 11.85 multiplied by the distance 0 to 2. I just cut it uh, here. I take distance 2, so distance 2. The answer is M. This one will go to the outside, so it should be 23. This one is moment at 2 meter distance. Okay, just cut it again. Okay, cut it again and just hit the middle point. So it is same. Okay, there is spot for the 0 and this one is the UDL. Okay, so the total distance of this beam is here is 2, here is 3, so it's 5 meter. This one is normal, shear and more. So I already did. Here is the point load will be 9 and the distance will be 1.5. Okay, so if you use the f of y equation for shear and then moment equation, so let's move to here and let me try f of y. Okay, upward will be positive, the downward will be negative, so v is going downward and 11.85 is going upward. So here is 9 is also going downward, so it will be 0. So v equal to 11 minus 9, so it's 2.85. Okay, kilometer. So use moment equation. This one is positive, so 11.85 multiplied by total distance was 5, and this one is negative, and the second one is going downward, so it's positive. 9 multiplied by 1.5 plus equal to 0. So this one will be 11.85 multiplied by 5. The answer is 59. Okay, plus here is 9 multiplied by 1.5, so it's 13.5 plus m equal to 0. This one is negative, so 59 minus 13.5, so it's 45.75 equal plus m equal to 0 negative, so it will be equal to the outside. This one is moment at the second point, so we get it here. You see, I get it here, but the what I did take this distance, so it's 5. So let me cut here before 20 and then I will cut it after 20. Okay, so let me draw the diagram. Now I'm cutting 11.85. Okay, there is force for the 0, here is UDL, and here is 20, but let me cut it before 20. Okay. This one is UDL, it was 9 and this distance was 1.5. Okay, the total distance was 2, 3 and 2, so it means 7. Okay, here is normal, because there is no x forces, the normal is always 0 m, and here is v. So apply f4 equation to find the v. Minus v minus 9 positive 11.85 to 0. Okay, there is no upward or downward force, so that's why this, and the v is also same as 2.85 kN. There is no change in shear force, because from this point to this point there is no force, that's why it's same. So let's apply moment equation. This one is positive, and let me try to find the distance. 11.85 is going this way, this direction, so it's negative. Multiply by the total distance is 7. Same, the 9, this one is negative. The 9 is going same, here is, so it's 9 multiplied by 1.5 plus 2, so it's 3.5 plus m into 0. Okay, so 11.85 multiplied by 7, the answer is 82.95 plus 9 multiplied by 3.5. Yes, it is 31.5 plus m to 0. So here the answer will be 82 minus this answer, so is 51.45 minus plus m equal to 0, so m will be 51.4. The answer will be positive kilometer per minute. Okay, this one is the moment at 7 meter. So now cut it the last point. Okay, let's try again. Okay, here is 11.85. Okay, here is the UDA, which is 9 kilometer, and here is 2 meter, here is 20, and here is normal, shear and moment. Okay, let me apply a proper equation. Let me try to figure out. Okay, so 11 is going upward, so it's positive. 9 is going downward, 10 is going downward. Okay, and v is going downward, so equal to 0. It's 21, 29 minus 11, so it's 17.5, minus v is going this way, so it's negative, and this is also negative. Okay, so moment, and moment is, this one is positive, so 0.85, 11.85 multiplied by total distance. Okay, and this one is will be negative. The 9 multiplied by 1.5. Okay, 1.5. Here is 2, and here is also 3. So 3 into 5, 6, 6.5, and same 20 is going positive. 20 multiplied by the distance from 20 to last point, so it's 3 meter. So this one will be 3. Okay, so 20 multiplied by 3 plus m equal to 0. Okay, so let me do this one. 11.85 multiplied by 10, so it's negative 118.5 plus 9 multiplied by 6.5, so it's 58.5 plus 20 multiplied by 360 plus m equal to 0. So 58.5 plus 60 is 118.5, so it's negative 118.5 positive 118.5 plus m equal to 0, so m will be equal to 0. Moment at the ended point is 0, so let me draw the shear force and bending moment diagram of these values which we get it from the equation. Okay, so check this picture. So here is the beam. This beam here is 11.85, so it's going upward, and here is 17.5 something. So here is negative 17.5, here is 11. Check this, there is no port, so it's going straight. Then there is UDL, so it will be down from like incline because there is UDL. Then there is no port, so it's go to straight. Then it's downward 20, so it's downward 20. Then there is no port, so it's go straight. There is support straight 17.5 upward, so it's 0. Okay, here is the same answer. It's 23. First point we get 23, then 45, then 50 something, and there is 0, so it's straight to 0. Shear force and minimum.